Waterfalls always attract attention. That's because falling water has power. It has the power to move wheels, to grind grain, to saw planks, or to spin yarn. Mills popped up all over Ohio in the early 1800s as settlers moved in. A man named George Wallace built a sawmill here at Brandywine Falls in 1814. His family ran the mill here for 40 years. But the power of a waterfall can do more than move machinery. It has the power to move the human heart. The motion, the mist, the endless flow. People are always drawn to waterfalls, if only to soak in the spectacle. A waterfall is obviously what happens when a stream or river runs over a steep drop. Let's look at the geology that makes this stream bed a gorgeous waterfall. The water of Brandywine Creek falls 60 feet from the bridge to the bottom of this little gorge. The reason it's a steep drop is because the stone at the top is harder than what's underneath. You can see the shelf of sandstone at the top of the waterfall. It's called Berea Sandstone after the town of Berea, and it's harder than the rock underneath. Most of that is a softer material, a type of hardened mud called shale. The layers of shale wear away and crumble a lot easier than the harder sandstone. By the way, when shale is heated and compressed underground, it forms slate, which is what chalkboards and old roofs are made of. As the bottom shale layers crumble away here at Brandywine Falls, the top of the waterfall also falls to the bottom, like those large blocks piled up at its base. The shale layers were deposited around 400 million years ago, when this area was all part of a shallow sea. That was a long time ago. Brandywine Creek feeds into the Cuyahoga River, otherwise known as a tributary. The beautiful Cuyahoga Valley formed around 10,000 years ago after the last ice age. Here we are, Blue Hen Falls in the Cuyahoga Valley National Park. Very similar to Brandywine Falls, with a layer of Berea Sandstone on top, a hard layer underneath shale that's much softer. You can see the overhang of the top layer. Eventually it's going to fall off, just like these big rocks here. Here we are at Tinkers Creek in Bedford, Ohio, with more examples of how geology forms waterfalls. You can see a big slab of Berea sandstone on top of softer layers of Bedford shale. This is actually where Bedford shale gets its name. A geologist came here and decided, let's call it Bedford shale, from the city of Bedford. This is Tinkers Creek, and that's the Great Falls of Tinkers Creek, a major tributary of the Cuyahoga River. Back when a shallow ocean covered this part of Ohio, silt and sand from the muck at the bottom formed these shale layers, which we now call Bedford shale. Later, sand from rivers and the beach formed the sandstone around 370 million years ago. So you're out and about, you can look at nature, you can look at geology, you can look at human-made structures like this pylon from the mill built in the 1800s out of Berea sandstone.